going to talk about matrix multiplication, and then I want to talk about finding matrix inverses by using Gauss Jordan row reduction operations. To find matrix inverses, we're going to use the Gauss Jordan process, but first I want to do multiplication. We say this is a 3 by 2 matrix because it has 3 rows and 2 columns. And I call this a 2 by 4 matrix because it has 2 rows and 4 columns. And to find matrix multiplication, these two numbers have to be the same. Which means, notice, if I rewrote these matrices in the opposite order, the order of 1, 2, 3, minus 1, minus 2, 0, 1, 5. That was one matrix. And then I had negative 2, 4, 3, 0, 1, minus 2. Since this would be a 2 by 4, and this would be a 3 by 2, since these numbers are not the same, I can't multiply the two matrices in this order. So matrix multiplication, we say, is not commutative. You can't flip it back and forth. This is matrix A and this is matrix B, and I'm about to figure out and calculate what matrix A times B is. That's fine. But if I try to do B times A as a matrix multiplication, that's just not going to work. So these two numbers have to be the same, and my answer is going to be these two numbers. So notice here the answer matrix that I've got already set up here is got 3 rows and it has 4 columns. That's based on this 3 and this 4. Here's how the matrix multiplication process works. This first spot, it's in the first row and the first column. I pick the rows based on the first matrix. I pick the columns based on the second. And here's what I've got. I get negative 2 times 1 plus 4 times negative 2. Then, for the first row and the second column, I'm still in the first row with matrix A, but I'm now picking things from the second column. So I have negative 2 times 2 plus 4 times 0. Now I'm in the third column. So I'm going to be in the first row again from A, but now I'll be in the third column from B. So I'll get negative 2 times 3 plus 4 times positive 1, getting that positive 1 from this term right here. For my last row, the fourth row, I'm going to get negative 2 times negative 1 plus 4 times 5. Again, grabbing that from this fourth column here on B. Now let me erase some of this stuff here so I've got room to see what's going on. Alright, now I'm getting ready to go into the second row. For the second row in A, I'll keep on using the second row of A. And then again, depending on whether I'm in column 1, 2, 3, or 4, I'll use columns 1, 2, 3, or 4 from B. So in this first spot right here, I'm going from the second row of A, and I'm multiplying it through by the numbers from the first column of B. So I have 3 times 1 plus 0 times negative 2. For the second column, I'm going to have 3 times 2 plus 0 times 0. For the third column, I'm going to have 3 times 3 plus 0 times 1. And I'm doing this out here in longhand. I mean, every time I have this times 0, of course, I'm not going to actually have anything. If I was actually multiplying these matrices together for real, I wouldn't write this out, but I'm writing this out here to emphasize what's going on. And then for this fourth column business, I'm going to have 3 times negative 1 plus 0 times 5. And last, let's get rid of all this. clean this up just a smidge. Lastly, I'm going to have my third row, because I'm in the third row. And again, let's grab that first column. 1 times 1 plus negative 2 times negative 2. Second column, 1 times 2 plus negative 2 times 0. Third column, 1 times 3 plus negative 2 times 1. And lastly, fourth column, 1 times negative 1 plus negative 2 times 5. I recommend that you practice this hand motion where you use your left hand to go from left to right, and you use your right hand to go from top to bottom. And that tells you move yourself left to right on A, and get, let's say, for this last part right here, we've got ourselves 1, we got the 1 there, and then you're going to get the negative 2. And as you're moving from left to right on A, you're moving yourself from top to bottom on B. So you get negative 1, so you get positive 1 here from the A, and you get yourself negative 1 here for the B. And you move your left hand to the right, and you get yourself negative 2. And you move your right hand down, and you get yourself positive 5. The last step is to simplify this out in this 3 by 4 matrix. So I get negative 2 minus 8, which gives me negative 10. I'm just doing these underlines. We don't normally write these in a matrix. I'm mainly putting these out here so it's clear what exactly is going with which. Then I get negative 4 plus 0, so that's negative 4. Negative 6 plus 4 gives me negative 2. Positive 2 plus 20 gives me 22. Go down to this row. Notice all of these guys have a 0 as a second term, so I'm not going to have any calculation to do there. This is going to give me 3. 3 times 2 gives me 6. 3 times 3 gives me 9. 3 times negative 1 gives me negative 3. Finally here I have 1 and positive 4, so that's going to give me 5. 2, that 0 is going to make it just 2. 3 minus 2 gives me 1. And this was a positive 1. Don't let that, that's an extraneous little dash there. It wasn't actually a minus. You can see it's not actually a minus because it's right here. So that was a 1 times negative 1, so that's going to give me negative 1 plus, and I have 5 times 2, but that's negative, so that's going to give me negative 10. So this will leave me with negative 11. If I haven't made any addition mistakes, this is my final answer for matrix multiplication. That's the multiplied matrix. And again, it's a 3 by 4 matrix because this guy had a 3 here and it had a 4 here for the part B. So that's matrix multiplication. Now remember, for my Gauss Jordan Row operations, there's 3 things I'm allowed to do. I can add 2 rows together. I don't know what that word's trying to be, so I can add 2 rows. I can multiply 1 row by a non-zero number, or I can swap 2 rows. So let's find the inverse of this matrix right here. Here's how you find a matrix inverse. You've got the matrix you're trying to find the inverse of. You create yourself an augmented matrix, and you augment it with the identity matrix. Now we're just going to use row ops and tackle this a piece at a time. Because I'm trying to get, now here's the one thing we're going to do. In my first, what I'm shooting for is I want this left-hand side to turn into identity. And whatever row operations I use here from these to make this happen, it's going to end up changing the matrix on the right side of the augmentation as well, and that's going to give me my inverse matrix. And then I'll show you at the end how you can do a multiplication check to make sure you actually got an inverse. So when I'm doing that, the first thing I'm interested in is in this first row, I want the pattern 1, 0, 0. And a way I can get that to happen is if I take this 4 and I convert it to a 1, and then I use row operations to convert this to a 0 and this one to a 0 as well. We would have a phrase for this. I would say that I pivot about 4. That's the language your book's going to use. So I'm pivoting about the 4, in particular the 4 I've just circled, the top 4. And all that means is that I'm going to take a particular number in a particular column, and I'm going to change that number into the 1 of the column, and the rest of the numbers in that column are going to be 0. This will be important when we get later on in the textbook and start dealing with some other things. So again, I'm not conducting a vocab class, but pivoting around 4, and I've circled the 4 that I'm pivoting around in this row. Here's how I'm going to get there. Anytime I write a row first, that means that row is going to get changed. Anytime I write a row second, I'm going to use that row to change it. So I'm going to do row 1 plus row 2. This means that row 1 is changing, row 2 is going to stay just the same. And because I want to, I'm also going to do row 3 plus row 2. I'm allowed to do more than one matrix operation per every time I rewrite the matrix, provided, notice right here, both times it's row 2 that's not changing. So row 2 didn't change when I did this first thing, and so that means I get to reuse row 2 again if I want to mess with row 3. That's not going to cause me problems. I couldn't talk to you about row 3 plus, let's say, row 1, because row 1's getting changed here at the beginning, and so I'm not allowed to sort of double dip in that way. So again, rows 3 and row 1 are going to be changing, and I'm going to use row 2 to make that happen. Here's what I get. Row 2 is not going to change, so just to be sure, I'm going to copy row 2 down just as he is. Negative 3, 4, 1, 0, 1, 0. Now row 1 is going to change, and it's going to change because I'm going to add them together. So 4 plus a negative 3 is going to give me 1. Negative 2 plus 4 gives me 2. 6 plus 1 gives me 7. 1 plus 0 gives me 1. 0 plus 1 gives me 1. 0 and 0 gives me 0. Notice I've got something I want already in this first row, namely I've got that 1 right there. And as a part of getting the matrix operations to do that, something over here has already started to change from identity. This far side is already starting to look more like what the inverse matrix is going to look like. Do it again on the third row. So negative 3 plus 4 gives me 1. 4 plus negative 1 gives me positive 3. 1 plus 6 gives me 7. 0 plus 0 gives me 0. 1 plus 0 gives me 1. 0 plus 1 gives me 1. I'm not done. I want to keep on changing some things. I'm going to erase this business about pivoting and give myself some space. I want this number right here to be a 0. The way I'm going to do that is I'm going to get there by doing row 2, because that's the row I'm changing, plus 3 times row 1. I'm messing with row 2, so that's the one that's changing. That means row 1's not going to change. And also row 3 is not going to change. I could have, again, tried to do more than one thing in one step, but I'm just going to keep it simple this time. I'm doing row 2 plus 3 row 1. And again, I figured that out because I want this to be a 0, and I have to use either row 1 or row 2 to get there. And the way I turn negative 3 into 0 is to do negative 3 plus 1, and I do it 3 times. All right, so I've got negative 3 plus 3 times 1, which gives me 0. I've got 4 plus 3 times 2, so that's 4 plus 6, that gives me 10. I've got 1 plus 7 times 3, that's 1 plus 21, so that's 22. I've got 0 plus 3. I've got 1 plus 3. And I've got 0 plus 3 times 0. All right, I'm getting there. I've almost pivoted my first column. The last thing I need to do is turn this into a 0. And the way I'm going to do that is to use the top row. And the way that's going to happen is I'm going to do row 3 minus row 1. Again, row 3 is the only one that's changing. I'm writing him first. That means row 1 stays the same. means also row 2 stays the same. Notice you want to be just careful enough that it's clear that I've got a 10 here and a 2 here. I don't actually draw these little box grid things, but it is one of the reasons why I like to have these little underlined spaces up here. Depending on how messy I'm feeling on a day, I'll give myself more or less in terms of reminding myself this is 10, not suddenly 1, 0, 1, 0, 2, 2 or something weird. This is 0, 10, 22. All right, I'm actually changing row 3, so let's do that. 1 minus 1 gives me 0. 3 minus 2 gives me 1. 7 minus 7 gives me 0. 0 minus 1 gives me negative 1. 1 minus 1 gives me 0. And 1 minus 0 gives me 1. All right, here's something cool that happened. Without me even trying, I got something that I was after. In particular, what I got is right here in the middle, I got this 1. That's something I want, because remember the pattern I want. I want 1, 0, 0, and then I want 0, 1, 0. So I'd like a 1 in this middle spot, and I can get a 1 in this middle spot if I do one of my row operations, particularly this one where I swap 2 rows around. So I'm going to swap 2 rows around. Some books have some different notation for doing that. I don't know, maybe it looks something like row 2 swaps row 3, but I'm mostly just going to do it. I don't normally write down a row swap. Keeping row 1 just as it was, but now what used to be row 2 becomes row 3. And what used to be row 3 becomes row 2. Okay, I've got some things I want. For this second column, well, I want to pivot around this guy. Excuse me. I've already got a 1 there. So now I need to keep on working. I need to turn that 2 above it into a 0, and I need to turn this 10 below it into a 0. I'm going to do that. How does row 1 need to change? Well, row 1 needs to get row 2 subtracted from it twice. And how does row 3 need to change? Well, row 3 needs to get row 2 subtracted from it 10 times. That's because 2 minus 2 times 1 will give me 0, and that's because 10 minus 10 times 1 will give me 0. Both these times, row 2 is not changing, so I'm going to copy row 2 out just as he was. Alrighty, so let's start to make this happen. I've got row 1 minus 2 row 2. So 1 minus 2 times 0 gives me 1. 2 minus 2 times 1 gives me 0. 7 minus 2 times 0 gives me 7. 1 minus 2 times negative 1 is 1 plus 2. That gives me 3. 1 minus 2 times 0 gives me 1. 0 minus 2 times 1 gives me negative 2. For row 3, I've got 0 minus 0. I've got 10 minus 10 times 1, which gives me 0. And I have 22 minus 0, and that's going to give me 22. Then I have 3 minus 10, and minus, it's going to be minus gives me plus, so I get 3 plus 10, which gives me 13. I'm going to have 4 minus 0. I'm going to have 0 minus 10. I'm almost done. The last thing I have to do is get this very last row to look like 0, 0, 1. Already got a 0 here for free. You'll find this happens quite a bit if you do the right row operations. There's lots of row operations you could do. There's lots, a horribly large number. I'm just picking one set. This is the set that seems to me to get me through to the end the fastest, with my personal preference of avoiding fractions if I at all can. I'm not going to be able to avoid them entirely. I need to convert this to a 1. It's not going to help me if I add row 2 ever, because if I add row 2, I'm going to start to get a number here, and I've just gone to a lot of trouble to make sure that number right there is a 0. It's also not going to help me to add row 1, because again, if I start adding or subtracting row 1, I'm going to have a number that starts to show up here, and we've gone to a lot of trouble to get this to be a 0. So now it's time to do one of our row operations where I multiply a row by a non-zero number. So I'm going to do 1 over 22 times row 3. All my other rows are going to stay the same, so I have 1, 0, 7, 3, 1, negative 2. I've got 0, 1, 0, negative 1, 0, 1. And now row 3 is going to change. 1 over 22 times 0 is 0, times 0 is 0, times 22 gives me 1. Then I get 13 over 22, 4 over 22, and negative 10 over 22. I'm going to reduce and simplify this just a little bit on the bottom row before I do anything else. So I've got 1, 0, 7, 0, 1, 0, 0, 0, 1. I've got 3, 1, negative 2, negative 1, 0, 1. 13 over 22 I don't think reduces, but 4 goes, 2 goes into 4 2 times, and 2 goes into 22 11 times. 2 goes into negative 10, negative 5 times, and goes into 22 11 times. The last thing I need to do is tackle this 7. So I'm going to do row 1 minus 7, row 3. I've saved this till the very end because I've got all these fractions here, and that's going to make this just a bit messy. Notice at this point, all of this is already part of my inverse matrix. The bottom row is going to stay the same. 13 over 22, 2 over 11, negative 5 over 11. My middle row is going to stay the same. It's my top row that's going to change. Notice when I'm subtracting row 3, there's these zeros here, so it's going to stay 1, 0, and 7 minus 7 times 1 gives me 0. Here's the part that's a little bit messy, so I'm going to shrink this top thing just a bit to give myself just enough screen room that you can see what I'm up to. All right, so here we go. Row 1 is the number 3. I'm subtracting 7 times row 3. So I'm subtracting 7 times 13 over 22. This is the same as 7 over 1 and 3 over 1. I need to find common denominators. 7 times 13. 7 times 3 is 21. 7, 8, 9. This gives me a 91 here, so I've got 3 over 1 minus 91 over 22. I multiply top and bottom over here by 22 over 22 to find a common denominator. 3 times 22 gives me 66 minus 91 all over 22. 66 minus 91 is going to be the opposite sign. 11 minus 6 is going to leave me with 5. 8 minus 6 is going to leave me with 25. So it's going to be negative 25 all over 22. And that doesn't reduce anymore. Next, I've got a 1 here. So I've got 1 minus 7 times 2 over 11. Again, that's the same as 1 over 1 and 7 over 1, which means I got 1 over 1 minus 14 over 11. So I've got 11 minus 14 over 11. This is just fraction addition, common denominators, multiplication, that sort of business. 11 minus 14 leaves me with negative 3. So I get negative 3 over 11. And finally, my very last spot for row 1 minus 7, row 3, I've got negative 2. And with that negative 2, I got negative 2 minus 7, row 3. And row 3 for this last spot is negative 5 over 11. And that's over 1, and this is over 1. These minuses cancel and turn into pluses, so I've got negative 2 over 1 plus 7 times 5 is 35 over 11. So this is negative 22 over 11. So I got negative 22 plus 35 all over 11. And 35 minus 22, I think, leaves me with 13 over 11. This right here is my inverse matrix. Negative 25 over 22, negative 3 over 11, 13 over 11, minus 1, 0, 1, 13 over 22, 2 over 11, and negative 5 over 11. I would take that, and that would be the inverse for this matrix: 4, negative 3, 4, negative 2, 4, negative 1, 6, 1, 6. So there's my inverse matrix right here. If I'd called that previous matrix A, this guy right here would be called A inverse.